Hello everyone, my name is Conor Kendrew. I'm the STEM coordinator at the Cornwall College Group. So this month I'm teaming up with the Wildlife Trust and the Your Shore project to deliver World Wellbeing Month. And what better subject to cover during this month than the well-being and the situation in the world of water. In these 3 short steps we're going to go through what water is, the science of water, what states it exists in, and the really cool things that it does to help our life function. The second thing we're going to cover is the global situation of water. So how is water held around the world? In what states does it exist? And how is the resource being affected by human activities? And then third, and most importantly, we are going to talk about the things that we can do in our daily lives to have a positive impact on how we manage water. This will benefit all of us and it will benefit the natural world. So come on, let's get started. Section 1. What actually is water? Well, water is what we call a chemical compound. It is a relationship between 1 oxygen atom and 2 hydrogen atoms. The reason this relationship occurs is because the oxygen needs certain parts of what the hydrogen has, and the hydrogen needs certain parts of what the oxygen has. Hence, they come together in this lovely relationship that we call water. Now, this is just 1 water molecule, but the next thing I'm going to show is how water sticks together and stays stronger together. Now, like I said, this hydrogen and this oxygen have things that they want to share with each other in order to become more stable. And that's exactly the same case when you look at 2 water molecules together. This oxygen and this hydrogen want to share some things together. And the same happens down here, which means that these 2 molecules become locked together in what we call a covalent bond. And this is how all of a body of water stays stuck together. It's actually through this chemical covalent bond that we get the water in our glass staying as 1 single substance. Pretty cool, right? And so that little bit of chemistry behind water hopefully explains to you why you sometimes see it written as H2O. That's because there are 2 hydrogen atoms and 1 oxygen atom making up 1 molecule of water. Now we're going to look at some of the different states that water might exist in. Water, like many other chemical compounds, can exist in 3 states. At 0 degrees and below, water becomes solid. Okay, we also quite often call this ice. So we draw a little ice cube for that. So that's below 0 degrees. From 0 degrees all the way up to 100 degrees, water exists as a liquid, and that is true water. So that is actual what we call water. And then, oh, don't forget the R. And then when we go up over 100 degrees, water becomes steam or vapour, and it outgasses and joins the atmosphere. Okay, so this is steam. Now don't confuse clouds with steam. Clouds are in fact water vapour or water droplets suspended in the air. So this is the states in which water lives, and every one of us sees these 3 states in our daily lives. You might also notice that the degrees Celsius is quite niftily standardised to the states that water is in. Now, these states change with altitude, but if you were at sea level, this is the different temperatures that water changes state at. Now, there's some other pretty cool tips and tricks and facts and figures about water that we're just going to cover, but I'll have to clean my board for that. Water, unlike most other compounds, is at its most dense at 4 degrees Celsius. Now, most things, when they get colder, they get more dense. But actually, when water goes from 4 degrees down to 3, down to 2, down to 1, and then finally freezes, it actually expands again, which gives us this amazing effect that water has, which I'll come on to in a minute, actually saves lives. So water, when it becomes ice, floats on top of the liquid water below it because it is less dense. Now, that does not happen with very many other compounds in this entire world, and particularly not with ones that exist as naturally as water. Now, why does this save lives? Well, this is a pond. Oh, this is a pond in the middle of winter, okay? And the pond, with all of its life in it, freezes. Now, have you ever seen a pond completely frozen solid? No, you haven't. And that is because this film of ice above actually acts as insulation for the water in the majority of that pond, which means that all the fish and all of the critters that live in ponds actually survive the winter despite the freezing temperatures, thanks to this property of water. Now we're going to come on to another property of water, and that is its ability to suspend and dissolve other chemicals and compounds within it. Water is also very good at allowing things to dissolve into it. One of the main compounds that dissolves into it is sodium chloride, and that is one of the main salts that make up salt water. Now, I think you'll be very aware that the sea is made up of salt water, and salt water changes the way that water behaves completely. It allows it to have a larger thermal mass, it responds to temperature changes in different ways, and in fact it actually shifts states slightly differently as a result of becoming salt water. But that's not the only thing that dissolves into water. Many nutrients and toxins and bacteria and viruses can exist within water. So it's very vital for plants to actually use the water pathways through their roots and into the main body of the plant to absorb different nutrients that the plant may need from the soil. The same goes for aquatic plants such as kelp in the sea. It actually brings in and draws its nutrients from suspended water. And then last but not least, toxins and contaminants in our waters affect our waterways greatly. They also affect the way that the environment works. It affects the organisms that live within that water. And so it's really important that we are aware water is not always just H2O. It can exist in very different states, as salt water, as water high in nutrients, or as water with toxins in it. And it's very important that we bear this in mind when we're thinking about the environment and also what water is good for us to use. So that was a little bit about what water actually is. Now we're going to come on and look at the global state of water. So the first thing we need to ask ourselves is, how is water held across the planet? And the first way we look at that is by doing this. 97% of the world's water is in the ocean. %97%. That means that 97% of the world's water is salt water. And that means that only 3% is what we call fresh water, or non-salty water. Okay, now that is staggering. But as we move forward, even more interesting statistics reveal themselves. Now, of that 3% fresh water, so I'll throw this out the way now, only 1% is surface water. 1% is surface water, or the water that you and I would see often, okay? 69% is in fact locked up in glaciers and ice caps. So 69% is ice caps and glaciers, okay? And then the remaining 30% is actually groundwater. So it's held in the ground beneath our feet. A lot of the earth is saturated with water. There used to be a lot more groundwater a few thousand years ago, but this is the breakdown of our fresh water. So only 1% is actually the kind of water that you and I would drink. And even of that, we're just going to come onto it, it's not such a clear picture after all. Okay, now let's look at that 1% of the 1%. So, once again, 70% of that is now what we call ground ice or permafrost, which is where the ground freezes permanently. So that's not melting anytime soon, or is it? Maybe. Okay, now 21% is in lakes. So that's a pretty decent number of that 1%. Just over 1/5 of those are held in the lakes of the world, like the Great Lakes in North America. They're an example of a very large lake system. And then the remaining exists, so there's 0.3% in the atmosphere. .3% in the atmosphere. We have about 0.5 in rivers, 0.2 in living organisms. And then there are some other small storages like soil moisture, for example. That's in that top layer of the soil as well. And so this is a breakdown, and hopefully what you can realise from looking at this is that a very, very, very small amount of the world's water, our lovely blue planet, is actually the kind of fresh water that you and I can consume. And that's why we need to be very, very careful about how we treat fresh water and make sure that we conserve it in our daily lives. You and I, we are quite complex beings. We are mammals, and mammals all around the world rely on water, and it's no different for us. We wouldn't survive very well without water for almost a week, and really we need it every single day in order to function properly. 70% of our body is made up of water after all. It's shocking then, and quite disappointing, that 1 in 9 people, which is almost 800 million people around the world, don't have access to clean water, meaning they have to walk miles and miles every day to collect water, or they simply have to drink dirty water that is going to make them poorly. This is seen by the UN as the fourth biggest crisis hitting humanity right now. And it's our failings, really, that we haven't been able to provide this to people or to conserve water correctly for people around the world. It's not just at the human level that this is being impacted. The very makeup of our countries is being changed. As climate change hits us and intensifies, weather patterns around the world and the water cycles of the planet are changing, meaning that whole cities soon could go without water. Famous day zero could be approaching for cities such as Cape Town in South Africa. Now, we need to change this, and we need to change this. But one other big impact that the water changes to the water cycle are having on us is in agriculture and the way we grow our food, which is also something we need every day. In regions such as New South Wales in Australia, for example, year-long droughts have had massive impacts on livestock stress and on crop failures. And of course, when the land goes without water for too long, storms can cause massive erosion and dust storms that result in soil loss and further land degradation. So this is a bit of a vicious cycle that we need to get out of. We need to find ways of managing water and correctly looking after it. A final point to make on the global situation is here in the little island of the UK. We are not without our water issues. Many of us can probably remember the summer of 2018, where drought lasted for almost 4 months. Now, the Environment Agency and the government themselves have released statements to let you know that we were almost at breaking point. And it has been in most people's living memories that water restrictions get brought in on people during hot, dry summers. We also have the flip side to consider, and that is that many of our homes are flooded by water because of the way that we mismanage it on our landscapes, in our towns, in our cities during the winter. So now we have an understanding of what water is and an understanding of the global situation that faces water. I'm going to take you around my house and we're going to look at loads of different tips and tricks and things that we can do in our daily lives to make a difference to the water situation. Okay, now we're out in the house and there are a lot of different things that we can do to save water. But it is important to know what is going to make the biggest difference. And that's why I'm going to start from the big ones to the little ones. The biggest changes and the easiest changes for us to make to the small little intricacies that we can do. And then we're going to wrap it up with a story about not just using less water, but saving more water, which I hope you're all going to like. Right, so number 1 is agriculture. And not just the agriculture that grows our food, but also fuels and fibres. This cotton shirt, for example, might well be one of the highest water demanding things that I interact with on my day-to-day basis. Agriculture is globally the biggest user of fresh water and we all depend on it, so it's something that's quite hard to get away from. The other thing that goes on is that we tend to demonise individual crops, and yes, avocados, almonds and cows and cotton and rice are all very, very big users of water. But what I want you to do is to have a thinking mind about where things come from and the situation that they have been farmed under. So this here is a pepper, and this pepper could have many different stories behind it. This pepper could have been grown 2 miles from where I live. It could have been grown in my greenhouse, but likewise it could have been grown in southern Spain with water that has been pumped up from underground in an aquifer. And the only way you or I are going to understand whether our pepper was bad for water or survived on natural water is by reading the labels and understanding where our food comes from. The same thing goes for these guys. Almonds. A lot has been said about almonds, and particularly the almonds that are used in California, where a lot of the aquifers are being pumped up, and a lot of communities have less water available to them because of the cultivation of these guys. The same can be said for rice as well. So we need to be careful with where our rice comes from. We need to read the labels on things and understand our consumption patterns. My top tips for this would be to reduce the amount of meat that you eat, okay? Be that means you don't eat it for lunch, or you have a meat-free Monday, or you go all the way and become a vegetarian or a vegan. It's entirely up to you. What's important is a conscious decision to consume less of it. Try to buy food that is local. Food is always better when we can go and see the farmer producing it. And then last but not least is try to be conscious of what you wear. Don't consume too many clothes. We don't need to have a different wardrobe for every month of the year. We can get by in using second-hand shops and by having a few less pairs of clothes that we wear all the time. Okay, that is food. The next biggest consumer in the household and as people is this thing, the shower. Far too many of us are taking too long in the shower. Now it is better to use a shower rather than a bath, but what we need to be trying to aim for is a shower that lasts only 5 to 10 minutes. These 15-minute, 20-minute showers are using up way too much water and it's not effective for cleaning. The other thing that we could try to do is reduce the amount of showers that we have. That means timing exercise and also looking after our personal hygiene in other ways, like using deodorant and wearing the correct clothing for the correct day. I know it's a little bit of a touchy subject to step on, but we do need to start thinking about the amount of water that we're washing ourselves in with the shower. Number 3, and again we're in the bathroom, is this guy, the toilet. Flushing a toilet is our third biggest use of water within the household. You might think this is pretty hard to get around this time, okay? We're not going to have smelly toilets just to try and save the water. But I've got a solution that maintains all of the household hygiene for everyone, and it's this. So these are toilet flush bags, okay? Well, they've got many different names and there's many different brands that you can get them from. But I've found also that Ziploc sandwich bags work just as well. What you're aiming to do is to fill up a bag like this with water. You can use maybe half a litre. And what you do is you take it and you put it in the header tank for your toilet. Now, for those of you that don't know how a toilet works, they have a little buoy or flotation device, and when that gets high enough, it cuts off the water. So by putting this bag in it, we got water here that cannot go down the toilet. It cannot be wasted, but it takes up enough room to mean that the header tank fills up less each time. Now over a year, that can save a very, very significant amount of water because it represents about 15% of the total water in this tank. So now you can flush your toilet with some confidence that you're doing something to conserve water. The next domestic water use we can start to cut back on is these appliances in the kitchen and in the airing cupboard. The clothes washer and the dishwasher. Both of which people tend to quite frequently put in half full. So half full of clothes or half full of dishes. And this is one behaviour change we really need to make. You should only be doing a full batch of washing and a full batch of dishwashing as well. Now, besides that, you also should have a quick wash option on your dials. And the same goes for a dishwasher. Please start to use that. For most food and for most clothes that get dirty, you should be able to get it out with just a quick wash. And also, it's nice to save in the electricity by just washing at 30. Alright? Now, other things we could do on that point is use the sink more often for washing dishes. Use a bowl while you're washing your dishes to recycle some of that water. And do you know what? Maybe keep some clothes back that you've worn once but aren't dirty. So there's all kinds of conservation techniques that you could incorporate into these heavy water users in your household. Okay, this is the last domestic water use that we need to address, and it is the classic British cup of tea. We all love to boil our kettle and we all like to get together and have a cup of tea every afternoon, but most of us in surveys have confessed to filling this up way too much and using too much water, boiling the kettle too often. So please be vigilant about putting the correct amount of water in your kettle and not wasting water on simple little things like a good old cup of tea in the afternoon. So that is the end of the water conservation techniques that we can incorporate into our daily lives and around our houses to reduce the bills and also help alleviate the massive demand that we put on water. Now we're moving from water consumption to ways of producing clean water and making sure that we harvest and store as much water as possible. In the UK, roof space and garage space and workshop space accounts for a massive area. All of that roof space is 100% runoff, which means that every raindrop of water that lands on it goes down into our storm drains and contributes to flash flooding. It may contribute to overwhelming the waterworks and causing leaks of sewage but also of storm drains. So it's a big issue that we need to address. One thing all of us can do is capture rainwater. Okay, just with the simple gutter and downpipe, install a water butt. You'll be very surprised to know that most roofs for a household are able to harvest enough water to meet the entire domestic annual demand of that household. Guarantee you're going to need a very big tank through the summer because we need to store that water back for the drier months. So this isn't going to be achievable for everyone, but we can all harvest a little bit. This is just a homemade example of a water butt. So we purchased a small water pipe tap just off of any old online store or a local DIY shop. Simply connected it to our downpipe, and now since last week's rain we've got plenty of fresh, clean water which we can use on the garden, which is absolutely perfect.